Hi dear students and viewers, welcome back to our channel Anvanay Kumar Basics of Physics. Dear students, in this video we are going to discuss about the multiplication of vector. Multiplication of vectors, in that especially we are discussing about the what is scalar product or dot product and what are properties of scalar product and how the questions will be asked from the topic of scalar product. Let's see. So children, my videos are so helpful to you. Watch the video up to last. So children, when we are multiplying the vectors, they may give two types. One is vectors, one is scalars. Simply multiplication of vectors. Here multiplication or product of vectors. Multiplication of vectors. So vector, if you can multiply the vector and vector, if they can give a scalar, then the product is called scalar product. Scalar product. If you can multiply the vector 1 and vector 2, if it gives a scalar, then the product is what we call scalar product. And again, if vector 1 and vector 2, if you can multiply these two, if it is used the another third vector, then it is called vector product. Vector product. So if you can multiply the two vectors, if it is the result is the scalar, then the product is what we call scalar. Scalar product always uses scalar. Vector product always uses vector. So if the multiplication of two vectors gives another vector, that is the vector product. Now we discuss about the what is scalar product and what are the properties here. So children, look here, on board one definition is there. What it is? If we can multiply two vectors is a scalar, then the product is called scalar product. And scalar product also called as dot product. Dot product. Clear? If A is one vector and B is another vector, then the scalar product should be shown by like this, A dot B. Clear? That should be equals to here mod of A and mod of B cos theta. The scalar product is given by the formula scalar product of two vectors. What is mod of A, mod of B cos theta. For example, here now this is the one vector A and this is the another vector B, and now this is the angle between. So here we are showing that this is now vector B, this is the so this is what it is, A dot B is equals to AB cos theta, like that. So children, very simple. This is the vector A and this is the vector B. Now it is A dot B is equals to AB cos theta. This is the angle. So here A dot B is a scalar. Clear? And that should be positive scalar. The given product of these two is a scalar, and that should be positive when the theta is less than 90 degrees. When acute angle, for that it is positive. Clear? Scalar is positive when theta is less than 90 degrees. And if the theta is an obtuse angle, then here then scalar is negative. So when for obtuse angle it is negative, for acute angle it is positive. Clear children? So this is simply about the definition of scalar product and its angle when the scalar is positive, when the scalar is negative. Clear? Children, examples of scalar product. Clear? So first thing is double is equals to f dot s. What is f? force, it is a vector, and what is S? Displacement, it is a vector. Then the scalar product of those two should be given by the formula as this is the what? W is equals to Fs cos theta. That is the first example. And now here second example is, here I am writing W is equals to F dot S. We are writing simply here. We are differentiating on both sides. dy dt of W is equals to F is constant and dy dt of S we are writing. Rate of change of work what we call power, and F rate of change of displacement what it is? Velocity. So therefore P is equals to F dot V. So P is the power and F is the force and V is the vector. So work is one example here and power is the another example. And now third one is pi is equals to B dot A. What is pi here? Magnetic flux. So if we can take, it is the magnetic field. In that field you have to take some particular area and you will make some angle with the magnetic field is theta. Then what, right? Pi is equals to BA cos theta. So most probably these three examples are best example for scalar product. Okay, now see the properties. The first one is scalar product can obeys the scalar product can obeys the commutative law. That means simply here A dot B is equals to B dot A. So these two are the vectors, these are also vector. A dot B is equals to B dot A. So children, for example, we are writing now A is equals to some 2i plus 3j plus some 4k, and B is equals to 3i plus 5j plus 10k. Clear? Now we can find out the A dot B. So A dot B is equals to, here with 2i plus 3j plus 4k and 3i plus 5j plus 10k. So dear students, we have to multiply the same I, j, k, k. So generally what we know, I, j, k are the orthogonal vectors. So I represents the x-axis, j represents the y-axis, k represents the z-axis. So we have to multiply the only the same vectors. So what it is, later we see. So 2 into 3, 6 I dot I plus 3 into 5, 15 j dot j plus 4 into 10, 40 k dot k. Then here 6 plus 15 plus 40. In this case, I dot I is equals to j dot j is equals to k dot k is equals to, here simply 1. So later we'll see why, because 6 plus 15 plus 40, 2 into 3 6, 3 into 5 15 and 4 into 10 40. Same here what you get. So 46 plus 15. So 46 and 15, 61. Here we are not finding any I, j, k like that. That means it is a scalar. A dot B is equals to scalar. In the same manner, you can write the B dot A also same thing. So B dot A. Here again what write? First you have to write the vector B. 3i plus 5j plus 10k of dot 2i plus 3j plus 4k. Here B dot A means what? Again 3 into 2, 3 into 2. Here what write? 2 into 3. Here now 3 into 2 I dot I plus 5 into 3 I dot I plus 10 into 4 k dot k. K dot k. In this case what write? 2 into 3 I dot I plus 3 into 5 j dot j plus 4 into 10 k dot k. Same thing. Here what you get here? 3 into 2 6. 6 I dot A means 1. 5 into 3 15 plus 40. So 21 plus 40, that is what again? 61. So children, the first thing is what? Scalar product can obviously commutative laws, because here what you got, A dot B is 61 and B dot E also 61. So like that, here the first thing is what? Scalar product obviously commutative law. And next property is that children, it can obeys the distributive law also. It can obeys the distributive law. So that is also we can prove, no problem. So it can obeys the scalar product, can obeys the distributive law. Distributive law. It is also called as associative law. Associative law. It is also called as associative law. That means A dot B plus C is equals to A dot B plus A dot C. Here the A, B, C are the three vectors. A dot B plus C is equals to A dot B plus A dot C. So it is also we can prove, no problem. So here very simple. You can take any vector. A is equals to 1i plus 2j plus 3k, and B is what, some here 2j plus 3j plus 6k, and C is equals to what, some 5j plus 5i plus 10j plus 20k, like that. So if you can substitute the vectors, we will get the same thing here. So if you can take any three vectors like A, B, C, then first you have to add the B plus C. You have to add the B plus C, and after that multiply with the A. And again what it is, we have to find out the individually A dot B and A dot C. If you can add again these two, we will do the same thing. So children, if you can do this one, you can easily prove that one. So it will take some lengthy, but watch it. First thing is what? B plus C, how to take. What is B plus C? 2 plus 2i plus 5j. What is 7? 2i plus 5i, 7i, and bj, sorry, 3j plus 10j, 13j plus 26k. That is what? B plus C. Now what do you write? A dot plus B plus C, how to write? Then what it is? A dot, what is here? J plus, sorry, 1i this is, so I plus 2j plus 3k dot 7i plus 13j plus 26k. Clear? So I 7 into 1 7 plus 2 into 13 26 plus 26 into 3 78 plus 26 plus 7 14 plus 4 21. So 9 plus 2 s, this is the triple one. So it is a scalar value. Now we have to find out the same thing by using the same relation here, A dot B and A dot C. So first thing you have to go for A dot B. What is A dot B? Here A is what it is? I plus 2j plus 3k. Again dot 2i dot here 2i plus 3j plus 6k. Then A dot B, how we can write? You have to multiply the same vectors. So here what it is? 2 into 1 2 plus 3 into 2 6 plus 6 into 3 18. So what it is? This is the 26. 2 into 1, I dot A means 1. 2 into 3 6, J dot J means 1. 6 into 3 18, K dot K is 1. Clear? Now similarly here A dot C, we can go for that. So what is A dot C here? A is what? I plus 2j plus 3k, and again what is? This is what? 5i plus 10j plus 20k. So again same, 5 into 1 5, 10 into 2 20, 20 into 3 60. Then what do you get? 20 plus 60 80, 85. So now we can add these two, A dot B plus A dot C is equals to A dot B, how much you got? 26, and this is what? 85. Then you can add these two, then what you get? 11. So 1 1 1. So what you get, children, here? A dot of B plus A dot of B plus C is what? Here what you get? Triple 1, and is also triple 1. That's why what you have to say, it can obey the distributive law or associative law. Okay. The letter I, and this is J, and this is K. Now in this case, children, we can write the first thing is here I dot I is equals to J dot J is equals to K dot K is what? That's first you have to know. So here I dot I means what, right? Mod of I, and what you know? A dot B means what? Mod A, mod B, cos theta, same thing. Here what we get? Cos theta. When we are taking theta, cos theta here, I vector represents the x-axis. One more vector is the I is there, it also represents the x-axis. So these two are parallel. These two are parallel. When they are parallel, theta is equals to 0 degrees. Then what, right? I dot I is equals to mod of I, and cos 0. Cos 0 value is 1. And here what we are saying, Ij, K are what we call unit vectors. Unit vector means what? Magnitude is 1. That's what, right? Mod I means 1, and this is also 1. Cos 0 also 1. That's what, right? I dot I is equals to 1. In the same manner, J represents both the same vector, represents the same axis. That's why J dot J also equals to 1. Therefore, what, right? I dot I, J dot J, K dot K is equals to 1. This is the thing you have to remember. And next thing here, fourth one. If you can take I dot J, J dot K, and K dot I, what we get? So here I dot J means what, right? Mod of I, mod of J, cos theta. Here I and J, how much angle is there? 90 degrees there. Then what, right? I dot J is equals to I, J are what it is? Unit vectors. Mod of I is 1, mod of J also 1, and this is the cos 90. Cos 90 value is 0. Therefore I dot J is equals to what, 0. Therefore I dot J, J dot K, K dot I is equals to 0. That's only in dot product we can multiply the only coefficients of I only. Okay. And next thing is here. Now same as this, if A is one vector and B is one vector, then mod of A, mod of B, cos theta. Here A and B are parallel. A and B are parallel. Then what is cos is 0. Cos 0 is 1. Therefore, mod of A, mod of B, we get it. Clear? Simply, what we write here? When they are parallel, A and B are parallel, what we write here? Simply, the dot product of or scalar product of two parallel vectors. Dot product of two parallel vectors is equals to the product of their magnitudes. Product of their magnitudes. Consider. So mod A, mod B we have. So when the question be like this, when the scalar product of two vectors is equals to the magnitude of their vectors, the question be like that. When it is possible, when those two vectors are parallel. Clear? And next thing is here, when we are go for next one, fifth one, I am saying now A dot B is equals to here mod of A, mod of B, cos 90 I am writing. Cos 90 means how these two are? These two are the perpendicular. Vector A and vector B are perpendicular. When they are perpendicular, obviously cos 90 value is 0. Then what you get here? It is a null vector. Clear? So next one is what? Fifth one? The scalar product of two perpendicular vectors. Perpendicular vectors gives a null vector. Clear, children? To understand very carefully in problems here, very simple. I am taking A is equals to AXI plus AYJ plus AZK. and this is another vector b, bxi, byj, bzk. Then the scalar product should be given by the like this: a dot b, vector a, vector b, and dot, like the scalar product. So then what write? Axi, ayj, azk dot bxi plus byj plus bzk. Clear? So just now only we discussed what it is. I dot I is equals to j dot j is equals to k dot k is equals to 1, and I dot j is equals to j dot k is equals to k dot I is 0, like that. So that's why here what write? A cross b, what we write simply here. That's why we have to multiply the only things I into I means 1, j into j means 1, k into k means 1. So to prove that simply here, I am going to do the entire thing here. First I am doing with ax into bx I dot I plus again ax into by, what write? I dot j plus ax into bz, what it is? I dot k plus similarly what write? Ayj, bx j dot I plus by j dot j plus bz j dot k plus again next third one az bx k dot I plus what it is again? Az by k dot j plus az bz k dot k. So children, just now only we discussed what it is. I dot I, j dot j, k dot k is equals to 1. Look here now. This is the I dot j and this is I dot k. So I dot j is 0 and I dot k also 0. And now j dot I, it is also 0. And j dot k also 0. And k dot I also 0. K dot j also 0. So here the final thing what you have? Simply ax bx I dot I plus ay by j dot j plus az bz k dot k. So that's why in competitive exams you can directly multiply the same coefficients of orthogonal vector. So here what you get? This value is 1, this value is 1, and this value is 1. Then what you get? A dot b is equals to what? Ax bx ay by plus az bz. This is the A dot b. And next children, if you can multiply the same, for example here A is there, then what you get? Vector A and vector A. Scalar product of these two gives the square of the vector. Angle between two vectors by using the scalar product. Let's see. This is the most important model children. So angle between vectors. So for example here A is one vector and B is the another vector. Then what we write children? A dot B scalar product of those two, mod of A, mod of B, cos theta. A dot B is what? Mod of A, mod of B, cos theta. Mod of A means magnitude of vector A and mod of B means what? Magnitude of vector B. From that what we write? Cos theta is equals to what, right? Vector A dot B by what, right? Mod A mod B. You can write A dot B by mod A mod B. So I will give an example children here. Find the angle between two vectors. Find the angle between these two vectors. So to find out the angle, we have to measure the A dot B, we have to measure, and mod A also we have to measure, mod B also we have to measure. So from that here what, right? First I am going to find A dot B. What is vector G? 2i plus j minus k. And here what is I minus k. Clear? So I minus k means simply what is here? J term is 0. Clear? So now 2 into I dot I plus here j 1 into 0 j dot j. Clear? So here I minus k can be written as I minus 0 j plus k we can write. Now simply here j 0. That means what? 1 j here minus 0 j here. So 1 into 0 j dot j. Then what it is? 0. Clear? Plus here what it is? Minus 1 is there, minus 1 is there. So 1 into 1 k dot k. Minus 1 plus 1. Then what you get here? 2 I dot I means 1. J dot I means 1. K dot k also 1. That's why 2 into 1 plus 0 into 1 plus 1 into 1. Then what you get? 2 plus 0 plus 1. That is what? 3. A dot B what you got? 3. Now in the same manner, what you have to find out now here? Mod of A we have to find out. Mod of B we have to find out. So dear students, if R is equals to xi plus yj plus zk, then mod of R means what? Under of x square plus y square plus z square, like that. So here A is there, then mod of A means what? Under of 2 square plus 1 square plus minus 1 whole square. That means what? 2 square means 4, 1 square means 1, minus 1 means what? 1. So under of 6. A value is what? Is mod of A is what? Root 6. In the same manner, mod of B, what is there? I. 1 square plus 0 square plus minus 1 whole square. I before 1 is there, I square. J before is 0, k is minus 1. Then what you get? Mod of B is what? 1 square plus 0 plus 1 square. That means what you get? Root 2. What you get? Root 2. Now you have to substitute the A dot B value, mod A value, mod B value in that equation. Then what you get, children? Cos theta is equals to formula use what? A dot B by mod A mod B we have. A dot B what you got? 3. 3 by mod A value is root 6 and mod B value is root 2. Then what right? 3 by 100 of what right? 12. 3 by root 12. So from that here I am going to write nowadays cos theta is equals to 3 by, I am going to write like 3 into 4. That means what? 3 by root 3 into root 4. So cos theta is equals to, again 3 can be written as what it is? Root 3 into root 3 by root 3 into it is 2. So root 3 cancel. What is root 3 by 2? So cos theta is equals to root 3 by 2. It is possible only when theta is equals to 30 degrees, because cos 30 is what? Root 3 by 2. So in this way we will find out the children angle between any two vectors by using dot product. Okay, children, projection of vector along the another vector. Projection of a vector along the another vector. This is the most important for competitive exams. Let's watch. For example, here children, this is the vector A and this is the component of vector A. That should be along vector B. And this is the vector B and it is the component of vector B along the vector A. So how we can find out that? So children, what you write? A dot B, scalar product of two vectors. What it is? A cos theta B, magnitude of B. What is A? A cos theta, component of A along B, and into what it is? B, magnitude of vector B. So from that what write? Component of A along B formula, what you can write? Component of A along vector B. How we can write? Very simple. How we can write? So is equals to what? A dot B by, yes, what, right? Magnitude of A, magnitude of B. Clear? That means what? Simply here component of A along B, what it simply A dot B is equals to A cos theta B. Then what required? A cos theta we need. A cos theta we need. Then what right here? A dot B by B. Simply A cos theta is equals to A dot B by B. This is the formula you have to remember. Clear? What is component of A along B? In the same manner, now component of B along A. This is another formula. Component of B along A. So what to write? A dot B means what to write? A B cos theta. A B cos theta. Very simple, children. What is A? Magnitude of A. Magnitude of A, and yes, B cos theta what it is? Component of B along A. Then obviously what, right? Simply what we require? B cos theta we require. Therefore B cos theta is equals to A dot B by A. Like this. This is the formula for projection of vectors along the direction of another vector. Clear, children? So in this case we can write, these are the scalar forms. These are the scalar forms. These are the formulas in scalar forms. If they can write in vector form, what it is? A cos theta is there. A cos theta. We can write A bar B bar by B like that. Then we can write simply here A B into B cap like this. B by B is a unit vector, and this is one more unit vector. This is the vector form. And same thing also it is there. B cos theta we can write A dot B or A cap B, like this. So these two formulas in scalar forms, and these two are in vector forms. So I will give now an example problem, then you may get idea. Okay. Find the relation of A is equals to 2i plus minus j plus k on I minus 2j plus k. So two vectors given. Find the projection of A. So projection of A, we have to find out what it is. Projection of A along or along the B. Clear? So already we know what we know. A dot B is equals to mod A mod B cos theta. We know. Now we can write A dot B. Projection of E was saying simply what, write A cos theta of B. We can write. You have to remember the formula. Direct formula. A cos theta what is? A dot B by mod B. This is the formula for what? So projection of A along B. Simply A dot B by B. Projection of A along the B. So we denote what we get? B. Therefore A cos theta is equals to A dot B 2i minus j plus k dot I minus 2j plus k. So 2 into 1. 2 plus I dot a means 1 plus minus 1 into minus 2, 2. J dot means 1 plus 1 into 1, 1. K dot means 1. 2 plus 1, that is what? 5. So A dot B what we got? 5. And what is mod B? Mod B value is what is root of 1 square plus 2 square plus 1 square. Then what you get? 1 plus 1 square means 1, 4 plus root 6. Therefore what you get? A cos theta is equals to what you get? 5 by root 6. A dot B is 5 and this is the root 6. Therefore A cos theta is equals to 5 by root 6. Vector component of one vector along the other vector. Let's see. Find the scalar component and vector component of A along B. So first thing is scalar component. Scalar component of A along B. What is the formula? A dot B is equals to A cos theta B. From that what, right? A cos theta is equals to A dot B by B. Clear? So this is the scalar component. It should be written as like this: A dot B cap. So vector B by magnitude of vector. What is simply here? Like that. And next thing is vector component. Vector component formula. Vector component. So simply A cos theta is equals to here A cos theta into B cap is equals to A dot B, and again like this. Along the B, that's why I am going to write A cos theta into B cap is equals to A dot B cap, B cap. So here B cap means what? Unit vector. Unit vector. Clear? So if you can idea about these formulas, you can easily find out the scalar component and vector component. Let's go for that. First thing is what you have to find out. A dot B you have to find out. So simply here A dot B class B means what? B cap. So B value what is? B is equals to I plus J plus K. And what is B cap means what? B by mod B. Mod B. B is what? I plus J plus K by mod B value what is? Under of 1 square plus 1 square plus 1 square. Then what you get? B cap is equals to I plus J plus K by root 3. This is the unit vector of B. Unit vector of B. Now for scalar component. Scalar component what is? A dot B cap. What is A? A means what? 3I plus 4J plus 5K of B cap. What it is? I plus J plus K by root 3. Clear? So simply you have multiplied that. 3 into 1, 3 plus 4 into 1, 4 plus 5 into 1, 5 into 1 by root 3. Then what are you telling here? 3 plus 4, 9, 9 plus 4, 9 plus 3, 12. 12 by root 3. Clear? So 3 plus 4, 7. 7 plus 5, 12. 12 by root 3. I am going to write like this. 3 into 4 we can write. 3 into 4 by S we will write. So again 3 means what? Root 3 into root 3 we can get 4 by root 3. Root 3 cancel. Then what you get? 4 root 3. So what is? 4 root 3 is the scalar component of vector A along B. That is what? 4 root 3. Clear? Now we can go for vector component. Vector component. So already what is the formula? A dot B dot again A dot B cap B cap. So already what you got value? A dot B cap 4 root 3 we got. Again what is the unit vector of B? This one. I plus J plus K by root 3. So root 3 cancel. Then what you get? 4 of I plus J plus K. This is the vector component of A along the B. So in this way we will find out the vector component of A and B. Vector component of A along the B and scalar component of A along the B. So I hope you understand. So children, these are the very important models. If you can understand this one, like, share, comment the video and follow my channel regularly. Thank you for watching.